students, welcome back to your one and only favorite channel, Tomachang Tutorial. Myself Kisan Kulung, and today we are ready to go for MCQ part of exercise 7.3 because we have already completed the numericals of exercise 7.3 and exercise 7.1 and exercise 7.2 and also the remainder theorem, isn't it? So please find the links below in the description and do watch those videos to better understand the concept of polynomials. Okay, so today we will right away begin the MCQ part. Let's begin. Question number 11. Okay, I have already copied the two questions 1 and 2. Number 1, let's begin. Which of the following is a polynomial in one variable? Okay, we are provided with these four options: option A, option B, option C, and option D. We are provided four options. Among these four options, we are asked to identify the polynomial in one variable. Okay, we are asked to identify a polynomial in one variable. Okay, let's check out with option A. X plus 2 upon x plus 3. This is option A. So this cannot be a polynomial, isn't it? Because we know that if we rewrite this x plus, we have the power of x 1 here in the denominator. So if we bring this x to the numerator, the power of the sign of the power changes to minus. It becomes minus 1 plus 3. Okay, the sign of the power is changed from plus 1 to minus 1 when we brought x from the denominator to the numerator. Okay, here we have the power plus 1, and when we brought this x to the numerator, the sign of the power changes to minus 1. Now, according to the definition of polynomial, the power of the variable should be positive integer. Okay, so this power is negative, isn't it? Power of variable should be positive integer, isn't it? So according to the definition of polynomial, the power of variable term should be positive integer, and this is a negative. So according to the definition of polynomial, this expression cannot be a polynomial. So this is not the option. This is not the answer. Let us go for option number B. Okay. So 3 root x can be written as 3x to the power 1 upon 2. 3 root x can be written as x to the power 1 upon 2 plus 2x to the power minus 1 upon 2, isn't it? Plus 5. This can be written as in this form. So according to the definition of polynomial, the power of the variable should be positive integer, and this is a fraction, isn't it? So, and this is negative fraction also. So this cannot be the option. Okay, so this is not a polynomial. This is also not the answer. Let us check out with this. Here the power of the variable x is 2. Here the power of the variable x is 1, isn't it? Root 2 x square minus root 3 x plus 6. Please remember, this root is only for 2 and this root is only for 3. Okay, so the power of x is 2, which is a positive integer, and here the power of x is plus 1, which is also a positive integer. So this is a polynomial. This is the correct answer. Okay, and here the power of the variables are positive integer, so this is also a polynomial, but we are asked to identify the polynomial in one variable, isn't it? The polynomial in one variable. We should keep in mind one variable, but we have two variables here. One is x and another is y, so this cannot be the option. The right option is option number C. Okay, here the variable is x and the power of variable is positive integer. I hope you got this. Now let's move on to the next question, number 2. Which of the following is a polynomial? We are asked to identify which of the following is polynomial. So this is a polynomial because the power of the variable is positive integer to the power 1. If there is no power, then we can understand there is always plus 1 as power. Okay, so the power of x is plus 1, so this is the answer, because which one of the following is a polynomial was the question, and this is a polynomial because the power of the variable is positive integer. So this cannot be the answer because variable is in the denominator, so when we take to the numerator, the sign of the variable, the sign of the power of variable changes to negative. This means this cannot be a polynomial. So the same thing applies here. X square, when we transpose this x square to the numerator, the power changes to x to the power minus 2. Okay, so the power of variable becomes negative. This means this is not the option. Here we have the power of the variable x as fraction 2 upon 3, which is not an integer, so so this is also not the option. Okay, so the correct option is option A. Which one of the following is a polynomial? This is the polynomial. This is not a polynomial, this is not a polynomial, and this is not a polynomial. Let's move on to the next question. Okay. Okay, now let's move on to the next question. Question number 3. Okay, which of the following is a linear polynomial? We are asked to identify linear polynomial among these 4 options. Option A, option B, option C, and option D, isn't it? There are 4 options given to us. Among these 4 options, we are asked to identify linear polynomial. First, let us understand what is linear polynomial. Linear polynomial means the highest power of the variable should be 1. Okay, linear means the highest power of the variable x to the power 1 plus 3. This is a linear polynomial because the power of this variable is 1. Okay, if the power of this variable is 2, we call this quadratic. Okay, and this is also called second degree polynomial because the highest power of x is 2. Okay, if the highest power of x is 3, third degree polynomial. Similarly it goes. Okay, we are asked to identify linear polynomial. Linear polynomial means the highest power of x or the highest power of the variable should be 1. Okay, now this is not the option because the highest power of x is 2, so this is not the option. Number B, this is the correct option, isn't it? Because the highest power of x is here, no number in the power, so we must consider there is 1 as power of x, so this is the correct option because x plus 1 has the power of the variable 1. X plus 1 means x to the power 1 plus 1, so the highest power of x is 1, so this is the correct option. This is not the option because the highest power of x is 2, so this is second degree polynomial. This is not even a polynomial. Okay, because if we rewrite this x plus, when we take this x to the numerator, the sign of the power plus 1 changes to minus 1, so the power of the variable is negative, so this cannot become a polynomial. So the correct option is B. Okay, linear polynomial means the variable having power, the highest power 1. Let's go for question number 4. Which of the following is a second degree polynomial? We are asked to identify second degree polynomial from these 4 options. Second degree polynomials means the highest power of the variable should be 2, isn't it? So this is not even a polynomial because root x means x to the power 1 by 2 minus 4. The power is fraction, so this is not a polynomial. This is not the option. This is also not the option because the highest power is 3, so this is a third degree polynomial. This is also not the option because the highest power of x is 3, so this is also a third degree polynomial. We are asked to identify second degree polynomial, isn't it? So the option D is correct one because the highest power of x is 2. Highest power of x is 2 means second degree polynomial. Okay, I hope you got this. Let's go for next question. Okay, now let's go for question number 5. The degree of the polynomial root 3 is. We are asked to write the degree of the polynomial root 3. Okay, we are asked to write the degree of the polynomial root 3. root 3 is a constant term, isn't it? Root 3 is a constant term. And what will be the degree of a constant term? Okay, suppose if I write a polynomial a x square plus bx plus c, ax square plus bx plus c, this c is a constant term, isn't it? Here the power of x is 2, here the power of x is 1, and here the power of x is 0. Okay, power of x is 0. Power of x 0 means anything to the power 0 except 0 to the power 0 is not 0. 0 to the power 0 is not 0. 0 to the power 0 is undefined. Undefined. Please keep in mind, 0 to the power 0 is undefined except 0, other than 0, anything to the power 0 is 1. Okay, if I write a to the power 0, 1. If I write x to the power 0, 1. If I write 10 to the power 0, 1. Anything to the power 0 other than 0 itself. Okay, anything to the power 0 other than 0 itself. 0 to the power 0 is undefined. Keep this in mind. Okay, 0 to the power 0 is undefined. Other than this case, anything to the power 0 is always 1. So we can write, here we have x square, here we have x to the power 1. In this case, this c is a constant term, and in this case we do not have x. That means we can write c into 1, isn't it? So instead of this 1, we can write x to the power 0. Got my point? X to the power 0 means x to the power 0 means 1. C into 1 is c. So x to the power 0. So the degree of this c is the power of the variable, isn't it? The power of the variable. The degree of this c, constant term, is the power of the variable, isn't it? So the power of the variable is 0 here. So option D is the correct answer, isn't it? Because root 3 is also a constant number like c. So a constant number has degree 0. Okay, the degree of the polynomial root 3 is 0 because the constant number except 0 has a degree 0. Okay, now let us move on to the next question. This is the correct option. This cannot be the option. These 3 also cannot be the option. Let's move on to question number 12. Okay, short answer type questions. Let us write the 0 of the polynomial px equal to 2x minus 3. Let us write 0 of the polynomial px equals to 2x minus 3. This means for what value of x the polynomial px is 0. This question, the question means for what value of x, the polynomial px is 0. Let us write the 0 of the polynomial px is this means. Okay, let px equals to 0. 0 of the polynomial means px equal to 0. Are you getting my point? So if px is this and px is 0, 2x minus 3 should be equal to 0, or x equals to minus 3, 2x, we have 2x, isn't it? Minus 3, when we transpose to the right hand side, becomes plus 3, or x equals to 3 upon 2, isn't it? So for x equals to 3 upon 2, when the value of x is 3 upon 2, this polynomial will have 0 value. Okay, 0 of the polynomial means when x equals to 3 upon 2, when the value of x is 3 upon 2, this polynomial will be 0. Let me check. 2, instead of x, I write 3 upon 2, okay, into 3 upon 2 minus 3. This 2 and 2 cancels out, so 3 minus 3 becomes 0. So px becomes 0, isn't it? So to become 0 of the polynomial, x should be 3 upon 2. Got my point? Okay, let's do the next question. The next question we have is question number 2 of 12, sub number 2 of 12. If p of x is x plus 4, let us write the value of p of x plus p of minus x. Okay, we are asked to find the value when p of x is add it with p of minus x, and the condition given to us is p of x is x plus 4. Okay, now let us find p of minus x first. Since p of x equals to x plus 4, this is the given condition, or p of minus x can be written as, instead of this x we write minus x, okay, because we have minus x here, plus 4, isn't it? So p of minus x is minus x plus 4 and p of x is this. So therefore we add this, okay, p of x plus p of minus x, isn't it? So let us add. We write the value of p of x here and then add with p of minus x. P of x is x plus 4, isn't it? This is given to us in the question. P of x is x plus 4, we write x plus 4, plus p of minus x is this, isn't it? Minus x plus 4. Get my point? Minus x plus 4, or x plus 4 plus into minus is minus x plus 4, isn't it? So plus x and minus x cancels out. 4 plus 4 is 8. I hope you got this. It's easy, isn't it? Let's move on to the next question, that is 12 sub number 3. Okay, let us write the remainder if the polynomial x cubed plus 4x squared plus 4x minus 3 is divided by x. Okay, we are asked to find the remainder when this expression is divided by x, applying remainder theorem. Okay, since we know that if the polynomial p of x is divided by x minus a, isn't it? Then remainder will be f of a, isn't it? If polynomial px is divided by x minus a, then remainder will be p of a, isn't it? So here in this case, if this polynomial is divided by x, what will be the remainder? So let px or fx equal to x cubed plus 4x squared plus 4x minus 3. Okay, and this is divided by x, isn't it? So we can say this is divided by x minus 0, isn't it? X minus 0 is x, so the value does not change. X can be written as x minus 0. So when this polynomial is divided by x minus 0, according to remainder theorem, remainder will be f0, isn't it? Remainder will be f0 or p0. Here we are using the term p, so we write p0, isn't it? X minus a, if this was x minus a, then the remainder would be pa. That's my point. If this was x minus a, then the remainder would be pa. So we have x minus 0, so the remainder is p0. So since px is this, so p0 would be, instead of x we write 0 cube plus 4 0 square plus 4 0 minus 3, isn't it? So 0 cube is 0 plus 0 square is 0, 0 into 4 is 0 plus 4 into 0 is 0, everything becomes 0, 0 minus 3. So 0 minus 3 is minus 3. The remainder, when this expression is divided by x, the remainder will be minus 3. Okay, let's move on to the next question. Okay, let's move on to the next question. Sub number 4 of question number 12. This is the last question from this exercise. Okay, we will complete this. If 3x minus 1 whole to the power 7 is a7 x to the power 7 plus a6 x to the power 6 plus a5 x to the power 5 plus so on, plus a1 x plus a0. Okay, let us write the value of a7 plus a6 plus a5 plus so on plus a0, where a7, a6 dot 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 a0 are constants. Okay, so we are provided with this value and we are asked to find the sum of a7 plus a6, means the sum of the constant terms, isn't it? So first of all, let me tell you that a7 x to the power 7 plus a6 x to the power 6 plus a5 x to the power 5. Now comes the term, there is not written in the question, but if I write, the term will be a4 x to the power 4 plus now comes a3 x to the power 3 plus a2 x to the power 2 plus a1 excuse me, x to the power 1 plus a0 x to the power 0, isn't it? Excuse me. First of all, what I would like to let you know is the power of the variable is decreasing. X to the power 7, then comes x to the power 6, then comes x to the power 5, then comes x to the power 4, then comes x to the power 3, x to the power 2, x to the power 1, x to the power 0. If you were asked to write the degree of this polynomial, then the degree would be the highest power of x, that is x to the power 7, isn't it? So the degree would be 7. Okay. Now, what I want to let you know is few information. Okay, this term where the power of variable is 0, x to the power 0, this term is called the constant term. Okay, the term whose the power of variable is 0 is called the constant term, and this term whose the power of variable is 1 is called the linear term. Please keep in mind, linear term. This is called constant term, this is called linear term, whose power of the variable is 1, and this term whose power of variable is 2, this term is called quadratic term. Quadratic term. Okay, these three terms has their special names: constant term, linear term, and quadratic term. Okay, this is to be kept in mind, and now we will proceed further to solve this question. Okay, we are provided with the value 3x minus 1 whole to the power 7 equals to this, isn't it? So we are asked to find the sum of a7, a6, a5 plus so on up to a0, where a7, a6 and so on up to a0 are constants. We are asked to find the sum of constants, isn't it? Are you getting me? Okay. What we do is let x equals to 1. Okay, we suppose x to be 1 throughout this equation. Okay, so let us put the value of x as 1. 3 into x means 1 minus 1 whole to the power 7 equals to a7 into x means 1 whole to the power 7 plus a6, isn't it, into x means 1 whole to the power 6 plus a5 into x to the power 5 means 1 to the power 5 plus a4, we need not write all this, so on, plus a1 x to the power 1 means 1 to the power 1, isn't it, into 1 to the power 1 plus a0 into 1 to the power 0. Are you getting me? Okay. 3 ones are 3. 3 ones are 3. 3 minus 1 is 2. 2 to the power 7 equals to 1 to the power 7 means 1 multiplied 7 times. 1 into 1 into 1, so on. 1 multiplied 7 times is 1, isn't it? That 1 into a7 is a7. Are you getting me? 1 multiplied 7 times gives the result 1. So 1 into a7 is a7 plus, similarly 1 multiplied 6 times means 1 into 6, a6 is a6 plus 1 multiplied 5 times means 1 into a5 means a5 and so on, plus 1 to the power 1 means 1, 1 into a1 is a1 plus 1 to the power 0 means 1, 1 to the power 0 means 1, 1 into a0 is a0, isn't it? Are you getting me? I hope you got. Okay, 2 to the power 7 means 2 multiplied 7 times. 2 into 2 into 2 into 2, 1, 2, 3, 4, 5, 6, 7. 2 to the 4, 4 to the 8. 2 to the 4, 4 to the 8. 8 at the 64 into 2. Isn't it? 8 at the 64 into 2. So 64 into 2 is 2 4 the 8, 2 6 the 12. This gives 128. 128 equals to a7 plus a6 plus a5 plus so on plus a1 plus a0, isn't it? We were asked to find the sum of a7 plus a6 plus a5 plus a4 plus a3 plus a2 plus a1 plus a0, and we have found the sum of a7 plus a6 plus a5 plus a4 plus a3 plus a2 plus a1 plus a0 to be 128. So this is the answer for question number 12 4. Okay, the last question of this exercise. Thank you so much for watching this video. Please subscribe the channel and click on the bell icon to get notifications for more video uploads. Okay, we will meet in the next video. We will do exercise 7.4 in our next video. Okay, till then, stay safe, stay healthy. Thank you.